Welcome student in our today's online section of subject mechatronics. Today we are going to see another concept of this chapter number 6. So in today's section we will see about the gates, then ladder diagram, symbols we are going to use in this ladder diagram, and the PLC operation modes. Okay, so let's starting from here. So there are the two types of this PLC operation is we are going to see here. First it is the input output module scan mode, and then next one it is the execution mode. You know that input output scan mode, it depend on the keys, push button, then gates, and execution mode, it is the mode where we are going to operate the either the motor or solenoid or the light. This is the execution mode. How we are going to do this is we are going to see in today's section. Okay, so during the input output module scan mode, during this input output scan mode, the processor updates all the output and input in the state of all input one channel at a time. The time required for this depend on the speed of the processor. Then this is next is the execution mode. So during this mode, the processor evaluates each rung of the ladder diagram. Here the rung, it is the connection between the input and output module. It is the horizontal line in the ladder diagram. What is this ladder diagram? I will teach you in the next slide. Actually ladder diagram, it is a diagram which is drawn along with the symbols and switches of this PLC, and it looks like a ladder. That's why we name it as a ladder diagram. Starting from the first rung and the processing to the last rung, the execution mode is there. As a rung is evaluated, the last known stage of each switch and relay contact is the range is considered, and if any true path to the output device is detected, then the output is indicated to the energize, that is set to the on. How this output is set on and how this is energized, you will get to see this during the operation of the various gates, which I will show you in the next slide. At the end of the ladder diagram, the input output mode is entered again, and all the output devices are provided with on and off state determined from execution of the ladder program. All inputs are sampled and execution mode is started again here. Here it is the PLC addressing. So in this PLC addressing, it is to identify the input output devices to the PLC use the device's address or channel. If the address designation depends on the types of programmable controller. Here the table shows a typical address designation from different input output devices. So the address for this input channel is from 00 to 07, and for output channel the address is from 08 to 15. For internal relays the address is 16 to 31, and for timers and counters the address is from 32 to 39. Actually this is the higher part of the electronics, but we just have the introduction it, so don't get worried, only focus on the main things which I am going to show you here. Only focus on the concept. This program diagram interpretation. In a program diagram, the on and off state of the output of the rung is determined by testing the element of the rung for a true or false condition. Here true condition means the output is on, and false condition is when the output is off. If a complete true element path to the output exists in the rung, then the output will be made true or on. Okay. Then program diagram interpretation. The symbol for a no contact indicates that the device should be interpreted as a false. If there is no contact, then the device is indicated as interpreted as a false. If the contact is tested and found to be open and true, if it is found to be closed, it is to be examined on, and if on, it is true. Means if closed, it is false, and if it is on, it is true. The symbol for here NC means normally close contact indicates that if it is tested and found to be closed, then it is false. If normally normally closed, it is false. If it is tested and found open, then it is on. Here it is to be examined off, and if off, it is true. Here you can see it is A, B and C. There are the three types of programming or diagram here. So here using a NC switch to be turned on a light when relay logic and with PLC programming. Here you can see it is a switch which is normally closed. You know that in A diagram the button turns the light off. Here it is normally closed, that's why this light is on. But if you are going to make it on, means you need to push it, it will makes the light off. Then with relay logic, here you can see on the second diagram, here with relay logic, when the button is turned, the light on. Here when you push the button, the light gets on. Here in C diagram, with a PLC program, the button turns the light on. Here on the, it is the light with the PLC program there. Then programming of a PLC. Here you can see the programming of PLC. It is the input module, this is the output module, and this in these two lines the switches and the lamp are present, and it looks like a ladder, so we call this programming of PLC as a ladder diagram. Here it is a ladder logic used for machine control. Function block diagram used for the process control. It is called as a ladder diagram because they resemble a ladder with two vertical rails. These are the two vertical rails L1 and L2 which supplies power as many rungs. This one is the rung 1. Many rungs are actually the rung refers to a horizontal line as they are control circuit to present. Here you can see this is the power rail, this is the right power rail, and between these the various rungs are connected. Here we are naming this rung as rung 1, rung 2, rung 3, rung 4, and last one is the end rung. Here there is a ladder diagram rung. Here it is the input and this output is form of the motor, and this input it is the switch, as this switch is normally open here, and this is the output which will be in the form of the motor or any other. So here it is normally open, so when this input is provided here in the form of block, then we will get the output. It is normally closed, so what is happening when you are operating this input switch, during this operation the output gets eliminated. Okay, so here when input is available, output is also available because this is normally open switch, and when you apply push there or apply force there, it starts on, and during on of the input we will get the output. But here it is normally closed, so when you apply push there, it gets off, and when the push is applied, the output is not present there because it is normally closed switch here. Okay, so this is again important part of this ladder diagram. Here we are going to see the elements. So these are the control relays. This is normally open relay, this is normally closed relay, and this is the CR1 means it is a control relay. These are the normally outputs here. First one is the motor, it is the solenoid, and last one it is the light. Then these are the time relay. This is the normally open relay, this is normally closed timer relay, and this is TR1, this is a time relay here. Again, these are the elements of ladder diagram. This is the mandatory action push button. It is normally open, it is normally close, push button. It is the physical limit, it is open and it is closed. It is a pressure limit. You only need to see the symbols here because the symbols are important in the ladder diagram. It is the pressure limit switch. It is the temperature limit switch. Here what is happening, as the temperature increases, this filament got extended and closed the circuit. This is the temperature limit symbol. Then last one is the level limit. So all these are the input or sensing modules. So this is the ladder diagram for AND gate. So you know this A and B, these are the switches. 0 means not activated and 1 means activated. You can say 0 is off and 1 is on. So during this AND logic gate, this one the vertical relay L1 and L2, and between this we have a range here. You may connect 4 type of range here, where 2 times this A is off and 2 times on. Same for the switch B also. So here what is happening, when A is off and B is also off, we have no output. 0 means no output and 1 means output, or 1 means on. When A is off and B is on, at that time also we will get the no output. When A is on and B is off, we will get no output. When both A and B are on, we will get the output. Here 1. The symbol for this AND logic diagram is like this. Here the lamp is energized only if contact A and contact B are simultaneously actuated at a time there. Now then this is ladder diagram for OR logic. Here this OR logic means either any switch A or B is energized, we will get the output. So here you can see, when both the switches are off, we will get no output, but either one among them is on, we will get the output, and when both of them is on, we will get the output as well. The lamp is energized if either any of contact A or B are actuated or both are actuated. This is for NOT logic. This NOT logic is like that: when input is provided, we will get no output, and when input is not provided, like 0, we will get the output. Here the lamp is energized if the contact is not actuated, and de-energized when the contact is actuated. Here you can see in this table here, when A is not actuated, we have the output, and when the A is actuated, we have no output. That's why we called it as a NOT logic diagram. Here for this AND gate, you can see here, this L1 is vertical relay, this L2 is the output vertical relay, and we will have 2 switches here, and we called it as the AND gate. I already taught you this AND gate. For AND gate actuation, we have both the switches actuated at a time. And for OR gate, you can see here, these are the 2 switches we are connected in a parallel, and when any of the switch is connected, we will get the output here. Similarly for NOT gate, if input is actuated, we will have no output. When input is not actuated, we will have the output. This is for NOT gate. Okay students, so this is enough for today. We will see the next section in the we will see the next topic in the next section. Thank you. We are stopping here.